Hey everyone, I wanted to take this time to go over chapter 6 and discuss lean and lean manufacturing. And this is a chapter that takes us through trying to figure out how can we make our production, our manufacturing processes more efficient through figuring out what are the different forms of waste that arise over the course of production. And once we figured out what are the different forms of waste, how can we then go about trying to make for a more efficient system? Okay, so this chapter is in has multiple learning goals. We're going to go through each and every one of these in depth, and I think I'll divide this into a two-phase video. This first portion here is going to be the theory of the chapter, and in the second video, we'll go over some of the quantitative aspects of the chapter. Okay, so we're going to be looking at in this first video on what's a lean system and how does lean tie into this whole notion of companies and corporations should have a focus on continuous improvement. Okay, and I'll also talk about how does this tie into the strategic vision of the supply chain of any given organization. Okay, so let's get started and talk about lean. So if you ever hear discussions about lean systems, lean manufacturing, we're basically looking at the organization, and for the most part here, I want to focus on manufacturing, even though lean can be used in organizations that do not have manufacturing. Okay, but for the purposes of this class, I want to focus mostly on manufacturing because that's where a lot of the big impacts of lean manufacturing arises. Okay, so lean manufacturing is basically a concept that focuses on how do we maximize value to the organization by figuring out what are the forms of waste. Okay, and as we go through this, we'll be looking at 8 different forms of waste and targeting how can we start a discussion as an organization to try and tackle waste wherever it may occur within the organization. Okay, so if you look at this diagram here from the textbook, I don't know if it's from textbook or whether I posted this separately. Whenever we're looking at lean, the whole concept of lean can be described by this picture here. Okay, consider a situation where we have an ocean, and at the bottom of the ocean we have certain rocks and landforms that could be detrimental to the boats traveling in the water, right? And now let's take this image here and translate it to what might be happening within a manufacturing environment. Okay, within manufacturing, there's a possibility that there could be issues that arise from material handling. Okay, if there's an inefficient system of handling material coming into the organization or being processed or being shipped out, there could be issues with machines breaking down or issues with quality control or issues with the training of employees. But the picture here also depicts water as inventory. Okay, now why is this important? Inventory is often used to buffer an organization or to buffer a manufacturing process against any situation that might arise over the course of production. Okay, so for example, if equipment breaks down, if the organization has inventory, then they could certainly satisfy the requirements of their customers, even though there's a system shutdown of some kind, and that's well and good. But the question that this brings then is how much inventory should an organization hold? Okay, how much end unit inventory should it hold for its customers? How much inventory should it hold at every step of the production process to ensure that the line continues running? Okay, so inventory can be a good thing, but having holding on to too much inventory can also be a negative thing. Why? Having too much inventory shields the organization from immediately realizing there might be a problem with the system. Okay, and if we were to reduce the amount of inventory and hold on to a basic minimum amount of inventory, and whenever a problem arises, for example, poor training, it will almost automatically be discovered that we have a problem, because that one aspect of the whole production process might lead to other issues with the system, and might actually even lead to a complete stop down or a complete stop of the production process. Okay, so lean systems focuses on not having just having inventory as a way of preventing production problems, but actually targeting what are the different problems that we might have that might lead to our systems shutting down, or might lead to a less than efficient output at the end of the whole process. Okay, so part of what lean systems entails is not holding on to a lot of inventory. In fact, a lot of companies that have a system that is considered lean have a just-in-time philosophy, okay, where their inventory is not held in-house, but they end up having contractual agreements with the suppliers to supply them with product on as a need basis. So if we expect to be using 10,000 parts of a given product on Monday, a just-in-time philosophy might be such that we expect our supplier to deliver product to us right before it's needed to go into production. Okay, so this obviously requires a very efficient communication process between the manufacturing entity and the suppliers, but it also requires that the organization has an efficient system in place to enable it to capture value from the system that focuses on not holding on to a lot of inventory. Okay, so just in time is a big part of lean. We also have, if I may move forward, the 8 forms of waste that I mentioned earlier. Okay, so companies that enact a lean system are basically trying to figure out ways to eradicate any of these 8 forms of waste that are mentioned here. The first form of waste, overproduction, occurs when a company produces more than what it should produce and ends up holding on to extra inventory, which might not be sold. And overproduction is considered a form of waste because we have situations where you might produce in anticipation of market demand, and it ends up being that the market is not able to absorb what has been manufactured, and so the company is forced to consider what to do with that extra product that they manufactured. Okay, so the question arises, should we maybe translate this overproduced product into maybe secondary product, sell it at a slightly lower price to try and encourage the market to buy more of the product? Should we consider scrapping it? Should we consider the product as being obsolete and not of much value? Or should we consider maybe doing some kind of a rework to tailor this extra product and make it more appealing to the marketplace? Okay, so a lean system tries to do away with this waste by considering a system that does not push product to the customers. Instead, it pulls orders. So it waits for orders to come in before starting that whole manufacturing process. Okay, so that way we're tailoring our production to what customers actually want instead of tailoring it to what we think that the customers want. Okay, so those purchase orders coming in then act as our trigger for the manufacturing process to be enacted. Okay, the second form of waste we have here, inappropriate processing, arises in situations where the resources that we use to manufacture product do not fully match what is needed to be able to give you the type of output we have. Okay, and this could arise in a variety of ways. I'll give an example of a situation where you have, say, an engineering manager doing the activities of the mailroom clerk. Okay, so when we have a mismatch between the resources that we have available to us, in this case an engineer, and the activities at hand, in this case sorting mail, that's considered a form of waste. Okay, in the same manner, if we're using really expensive, really high-end equipment to do something that could have been done by equipment or machinery which is could have been purchased at a much less value, but still able to accomplish what is needed to be accomplished, then we have a form of waste that we should take into consideration and try and figure out how could we ensure that we're not having a mismatch between what needs to be processed and the resources that we have available to process that product. Okay. The third form of waste we have here is waiting. And this has to do with what's the amount of time that product spends waiting to be processed along each stage of that assembly line or production process. Okay, and if I could draw a very basic assembly line here, and let's assume that we have a number of different workstations along the assembly process. Okay, and for each station we have an employee assigned to the stations. And excuse my drawing, but that's the best I can do drawing with a mouse. Okay, now assume that employee 1 can process, say, 100 units of product within the course of the day. Employee 2 can process 50 units, and employee 3 can process, say, 75 units of product during the course of the day. Okay, now because employee 1 has this output or this throughput of 100 subcomponents within the course of the day, by 5 in the evening when the day is done, he would have pushed through 100 units to this person here. And this person here is going to also incorporate what the first person has done, and then will push 50 units to the next person in the supply chain. And that's not 50, not 100, but 50. And then this last person can process up to 75 products. And if the second person here can only push 50 units of product to the last person, then we run into a situation where that last person might be idle for some time, waiting for product which might not be coming. Okay, and that could be a problem. Okay, so waiting is considered a form of waste if you have employees or if you have equipment or resources that are sitting idle waiting for parts to be pushed onto them to enable them to do what they need to do to move the subcomponents further down the assembly line. Okay, so the operations manager has to figure out how do we balance a production process, knowing that each and every step of the production process takes a different amount of time, takes a different amount of resources, and even for the people engaged in those different workstations, the amount of time, the amount of effort required might be different. Okay, so it's part of the operations manager's job to try and figure out how do we reduce the amount of imbalance between the different workstations, between the different parts of that processing line, to ensure that we have a much smoother flow of product throughout the system. Okay. The fourth form of waste, which is transportation, focuses on how much do we move product between the different parts of the production system, right? If there's any unnecessary movement of product, we will seek to find ways to eliminate those unnecessary moves. Why? When you are touching and moving product from place to place, there's often the possibility that it could be damaged. If it involves, say, a forklift movement, the possibility that that product might be damaged in transit goes up. Okay, the operations manager or the production manager then has to figure out how much movement is really essential and how much of the movements that we currently have as an entity could actually be eliminated, such that we're reducing the amount of time that product is touched when it's not being processed. Okay. The fifth form of waste has to do with motion and has to do with personnel themselves. Okay, when personnel are in the process of manufacturing product, there's a lot of movement of the body. There's a lot of holding on to stuff, reaching out for stuff, and This form of waste focuses on the fact that if we could reduce the amount of motion, okay, we both conserve the energy of the employee, but at the same time, we reduce the potential, again, that product might be damaged, okay. We reduce the probability that an injury might occur. And so in this case here, this is something that an industrial engineer might do, which would be to try and figure out how can we make our workstations in a manner that's going to reduce the amount of motion and focus more on what motions actually are truly required to enable the employee to achieve whatever production or the production of any part that the employees engage in. Okay. The sixth form of waste, we talk of inventory, is one that's pretty critical because inventory is actually a form of capital. And inventory, if we are holding on to excessive inventory, then basically what happens is it's like having money sitting in a warehouse doing nothing, waiting for somebody to come and pick up that inventory and use it in the production process. Or if it's excess end product inventory, then it's just money sitting there waiting for a customer to hopefully purchase the product. Okay, so this is one place that, because of the focus on cost reduction, companies that have an inventory strategy will focus on trying to figure out how much inventory do we actually truly need to satisfy production and to satisfy the end customer. Okay, and how much inventory, how much safety stock inventory should we also keep on hand, because different production processes and different products might require different levels of safety stock. Okay, if we had a system where we knew for a fact that every month our customers order, say, 10,000 units of product, okay, and it's consistent January through December, then chances are that our safety stock inventory requirements would equal zero. Okay, the amount of risk associated with such a system is pretty low, and so our safety stock calculation, when we get to doing the math, will give us a number of very close to zero, knowing that there's little risk, there's very little variation in demand from month to month, and so we'll hold close to zero safety stock. If, on the other hand, we have a product that has a monthly, let me clear this out first. If, on the other hand, we have a product which, if we're looking at sales from January through December, we see spikes and valleys in the graph, like something like what I'm drawing here, then we have a higher variance in demand, and we might want to then incorporate some measure of safety stock. Okay, and we have formulas for calculating what's the amount of safety stock that we should have on hand. Okay, within a lean system, we focus on not holding on to a lot of inventory. Okay, for most lean systems, we focus almost on holding on to inventory that's just enough to get us through what's needed to build inventory for a given period of time, say 1 day. Okay, so inventory is waste if we're holding on to too much inventory, and the prudent production manager should have an inventory strategy in place to ensure that that does not happen. Now, the waste form 7, which is defects, is a very significant form of wastage. Okay, and defects is basically anything in the product that might result in the product being rejected by the customer. Okay, defects are usually based on quality and what customers are willing to pay for. And when a product is received and it's not in the quality that the customer expects it to be in, then it becomes a defect, a defective product. Okay, and this is obviously one thing that companies try to minimize, because defects result in a whole bunch of different costs. Okay, if you catch a defect while in the production process, then it's better than catching a defect once the product gets to the customer, but it's still going to cost the company money in terms of there might be a rework that has to be done, some possibly tweaking of the product to make it go back to being 100% of a quality product. But if by chance that product ends up shipping to the customer and they find it defective, then we go into this whole process of reverse logistics, where the product has to be shipped back to the plant or to the store where it was purchased, and then the store has to figure out, what do we do with this product that's defective? Should we again make it secondary material and sell it at a lower price? Is it so defective that we should consider scrapping it for almost $0 value? Or should we send it back into what we call a rework, where we're again going to try and improve the product enough to be able to sell it again as prime product? Okay, and it also leads to the question of who then is responsible for this cost. Is it a defect that arose during the manufacturing product process? Is it a defect that arose from a supplier component, and so should we bill the supplier for the cost of that whole reverse logistics? Okay, but overall it's a very costly form of waste, and the fewer defects we have in production, the more profitable the operation will be. Okay, and the final form of waste here has to do with the employees. Okay, having employees on the shop floor or in an assembly line where they are not fully engaged over the course of the productive workday results in a form of waste, which is we term underutilization. Okay, so this is one part where human resources coupled with the industrial engineers or the operations manager have to figure out a strategy to ensure that they have the right number of employees needed for the purposes of production, and that the employees have the right amount of training and the right type of training that's needed to ensure that they're engaged in making a product that's, again, of high quality, and they're not slouching or sitting and wasting time waiting for orders to come in over the course of any given period of time. Okay, so Lean focuses on a reduction in these 8 forms of waste, and the different strategies that corporations use differ depending on the nature of the product, different depending on the form of waste that's being identified and hopefully being that the organization is trying to tackle. Okay, so just remember the 8 forms of waste, and you'll notice as we go through this chapter that there's a lot of wording that's in Japanese, and there's a reason for that. Okay, Lean strategy and Lean systems as we know it today arose from the workings of people at Toyota in Japan. Okay, and if you go back to the history, and you can look this history up online, and it goes back to the period right after World War II, where Japan had just been devastated after those 2 atomic bombs were devastated the economy, and they were picking up and trying to grow the economy and build an industrial system that would work for the people of Japan. Okay, and as Toyota was trying to manufacture vehicles, and they're trying to figure out what ways can we ensure that we have vehicles that are competitive globally, they decided to, I think the head of Toyota at that time was somebody called Taiichi Ohno, or Ocho, can't remember the name very well, but he decided to try and figure out ways to improve the quality of Toyota vehicles. And at the same time, there was a scientist and engineer in the United States called Edward Deming, who Toyota decided to bring over to be a consultant to try and figure out what are better ways to manufacture Toyota vehicles. Okay, so from this initial period after World War II, Toyota and a bunch of companies in Japan started focusing on quality. How do we make a quality product? How can we make a product that's of a quality high enough for export? Okay, and they did it so well that over time, the system that Toyota had in place became known as the Toyota Production System, or TPS. And this is where a whole bunch of the different aspects of lean system, the different terminologies that we have in lean system arise from. Okay, so Muda or waste is one of those terminologies that arose out of this whole push for more lean systems and figuring out the forms of waste. Okay, all right. So other things that are a focus of lean include the fact that for lean systems to survive, corporations that implement lean have to understand the suppliers well. In certain situations, they actually partner with the suppliers in ensuring that they have um, a pretty strong communication back and forth between the suppliers, and the suppliers know exactly what's needed of them. Okay, and this is important because in situations where suppliers might have shortages or they anticipate shortages, having that kind of close supplier ties will enable them to have information shared such that the business can then plan for situations where the suppliers may not have product available for them. Okay. Lean also focuses on having smaller lot sizes. Okay, so the different batches of product that is being manufactured, instead of having longer production runs, lean systems usually focus on shorter production runs with lots of setup for different products as needed by the business. Okay, all right. The lean system, I think I mentioned this before. Lean systems focus on having a pull method. Okay, and just to emphasize that again, pull methods focus on building product based off of customer demand. Okay, when customers place purchase orders, the company gets visibility into what does the market want. Okay, so as orders come in, a lean system will start building product in to be able to satisfy those purchase orders that have been placed with the company. Okay, that differs from a push system that focus on let's build up a lot of inventory, let's make a lot of product, put it in a warehouse, and wait for customers to purchase product. Okay, so that is essence of lean. Wait for the customer order. When the order arrives, then go ahead and start building product for the customer. Okay, let's look at a couple more Japanese terminologies which are important to lean. Jidoka is one that's gaining in strength and is one that's been recognized as having a lot of value. Okay, and this has to do with what we call automation. How do we build a system that can essentially run itself, right? The basic foundation to this principle of Jidoka is that computers and equipment often result in less errors, in less defects than when we have a human being doing things. Okay, computers, machinery often do not get tired. Hopefully they don't. And as a result of that, if there's anything that can be done by a computer, can be done by a robot, can be done by some form of equipment, then the company should try and figure out how do we purchase that equipment and bring it on board. The second part to that is once there's an error that's been realized, rather than just saying that it's a one-time thing, some learning has to occur. Okay, and that learning occurs by, Jidoka says, if we run into an error, stop the process, figure out what the error was. Is it something that can happen again in the future? If it is, get a solution for it such that it doesn't, it ends up not occurring again at some time in the future. Okay. That ties into Pokayoki, which talks about how do we then ensure that we've figured out all the different, or maybe brainstorm all the different errors that might happen in the system, and how do we then ensure that those errors don't end up harming the system. Okay, so we mistake-proof the system by knowing what could go wrong and having in place a system that's going to prevent those things from actually happening, knowing that it could potentially happen. Okay. The second part of this video, I'll talk about takt time and how uniform workstations can be achieved. But these are also something that are a pretty big part of the lean system. Takt time, in layman's language, is just basically how much time do we need to process customer orders given how much orders we have. Okay, so if our customers daily demand for product is say 10,000 product or 10,000 units of product, and it takes each unit of product say 20 seconds to be processed. Okay, the total amount of time that I would then need to finish making 10,000 units of product will be 10,000 units multiplied by 20. So I'll be looking at say 200,000 seconds, 200,000 seconds to be able to complete this order. Okay, so takt time is just basically how much time will we need to be able to satisfy this order. And takt time is usually compared to what we call cycle time. Okay, takt time versus cycle time. Takt time is how much time we need to process product. Cycle time is how much time does our current system actually take to manufacture product. Okay, so our takt time here is 200,000 seconds to make all that product that's needed within a given day. And we might find that, well, it actually takes our system 25 seconds and not 20 seconds to make one part. Okay, so our cycle times might vary from the takt time, and the objective in considering takt time versus cycle time is to try and figure out if we have a certain number of orders, will we really have the ability to build all the product needed to ship out to the customers, or should we then consider some other strategies, maybe using overtime, or maybe bringing on temporary employees, or maybe considering some other methods to ensure that our cycle time is able to match the takt time for the customers. Okay, and to accomplish that, we look at the uniform workstation loading, and this has to do with how much work does every workstation get, and how can we balance that out so that we don't have some employees working way much harder than others. There's how do we bring a sense of balance when different processes usually take different amounts of time. Okay, so our Heijunka talks to how do we achieve that uniform workstation loading from in a system with multiple workstations producing different components of one entire product. Okay. So that is that. Now, if you have time, I've posted on this, and these PowerPoints are available on Blackboard, but I've posted here an example of one of the tools of Lean, which is 5S, and this talks to basically having a system in place where the workspace where manufacturing is done, or where inventory is stored, is put in a manner that makes it easy for persons to access what they need to access when they need to access it. Okay, and the video will take us through, I believe it's a hospital system that had a problem with an inability to access product when it was needed because their storage was jumbled up, and so they had to find a way to better store different medical equipment, different medical supplies. And so they went through this whole 5-step process of sorting out what they needed. Okay, and when you sort, you actually find that you can come across things that really should not be in that workstation or workspace. Okay, you might have product that's obsolete that needs to go. You might have product that's stored in the wrong place and might have to be moved to a different part of the system. And then you might have product that should be put into one specific part of that system, but it's all over the place. So the sorting process is just basically cleaning up and trying to figure out what we have, what we actually have within that space. Then we move on to straightening it up. Okay, and this part involves trying to figure out how can we ensure that everything is in one specific part of that system, such that if somebody comes into that system, they'll know exactly where to go to get a given tool, to get a given equipment. And then once they have that in place, we go on to the shine, which is now let's clean up and make that system work. Once we've straightened it up, let's make it better. And then stage 4 says let's standardize it such that over a period of time, the system is standardized such that people know exactly where to go to get something. So the objective here is that if I was to be going to the system looking for a tool, and we had a pretty messy system where it might have taken me, say, 2 minutes here to get what I need from that space. By the time we get to a standardized system, knowing exactly where I need to go to get what I need to get, I should be able to maybe reduce the amount of time it takes searching for some product to maybe even 15 seconds. Okay. And once that's done, we go into the last step, which is how do we sustain the system? Okay, and this ties into the whole concept of continuous improvement. The fact that we went through this 5S process last year does not mean that there's no room for improvement. There's always going to be room for improvement. It's just that once we have a system in place, it's now easier to build upon what's already in place and to sustain this level of efficiency that's been maintained throughout the system. Okay, so that then I also have a video on the Toyota production system because I strongly believe that it makes sense for operations managers interested in trying to figure out what's lean all about to go back to the source of where this whole lean manufacturing movement began from. Okay, so the TPS system is built out of what we call the House of Toyota. Okay, and the House of Toyota basically describes how Toyota views quality as well as lean manufacturing. Okay, and I actually looking at one of the metrics that I look at is if you can go online and just look to see the length of time that vehicles stay on the road, okay, and which vehicles stay on the road the longest. Every single organization or companies like Car and Fleet that actually look into these things find that Toyota vehicles end up being on the road for the longest period of time, anywhere from 18 to 25 years. Okay, that's a reflection on the level of quality that these guys have achieved, and that quality stems from what we have here. Okay, at its foundation, Toyota believes in looking at how do we sustain the stability of operations. Okay, how do we ensure that our employees and workstations have a uniform workload? Okay, how do we standardize the work that is performed at every step of the production process? Okay, and what about our suppliers, the people, the different people who bring product into our system? That's a pretty significant component of the manufacturing process, and that's something that Toyota focuses on quite a bit, ensuring that the supply chain enables the same level of quality that Toyota expects within its manufacturing process. Okay, and then the Toyota production manufacturing environment is also a big part of that. Okay, Toyota focuses on a just-in-time system, so they don't hold on to a lot of inventory. Remember, that saves money because inventory is usually a lot of money that's put into having parts sitting in the system. Instead, it pushes its inventory control to its suppliers by telling them when they'll need product and having the suppliers provide them with product when they actually need that product. Okay, they focus a lot on ensuring that all the different errors or mistakes that might occur in the system have been thought through and have that they've put in place measures to prevent errors from happening. Okay, and they have a very strong culture of continuous improvement to the point where they have different groups of people coming together every now and then trying to figure out what are the different ways that we can improve each aspect of the production process. Okay, So what this results in, which is in the roof of the house of Toyota here, is significantly high quality of vehicles produced at a cost which is lower than most other manufacturers on the market. And it's been sustainable over time. Toyota vehicles are relatively affordable. They're not cheap, but they're relatively affordable compared to other vehicles on the market. And that's because this push for continuous improvement has dropped the costs associated with manufacturing their vehicles, okay, while not harming the level of quality that they've been able to accomplish. So that's the house of Toyota, and it's a good representation because it's a very simplistic diagram, but it's very transferable across different industries, across different corporations, and most companies can actually make sense of this and try and incorporate something similar to this and make for a pretty decent lean manufacturing system. Okay, the one worker multiple machine cells is a form of lean where we try and look at for each work cell, how can we make it such that the worker, the amount of motion, if you go back to the forms of waste, the amount of motion that the worker has is limited, okay? And if you see this circular system that they have here, this speaks to the fact that we could have this system set up in a way that all these 5 equipment could have been in a straight line, kind of like an assembly line, okay? And if that was the case, this worker would still be able to accomplish what he needs to accomplish. But now think about it in terms of movement. If I have to start making something here, then I move to the second workstation, then on to the third, then the fourth, then the fifth, and once I'm done, I have to go back all the way to work the first part of the machine 1, and that cycle repeats over and over. Then I have some waste associated with that motion, okay, which is different from this design that's shown in the graph here, where the person basically starts from machine 1, builds his way through all the 5 different machines, and once he's done, he's right back to next to machine 1. Okay, so basically eliminating machines, movements or motion that he might have incurred if the system was laid out slightly different. Okay, so these are things that are usually part of ergonomics, and most often within the manufacturing setting would be done by an industrial engineer, taking time to analyze the product, analyze what's considered waste, and analyze what this employee needs to do to be able to manufacture a given component. Okay, so the different things that an industrial engineer could do to ensure that the amount of motion, the amount of transportation is reduced. Group Technologies takes what we have here, but now focuses on what are the different process flows, okay? Especially for a much larger process, instead of just one workstation, one employee. What about if it is a whole entire plant with product coming in and then leaving at some point? How can we reduce the amount of motion? And Group Technology basically brings together all the different processes that need to be together, okay? And then processes that don't need to be together then relegated to a further part of the whole production process, okay? So the last part that I'll talk about on this video before I go into part 2, which is a bit of the math, is Kanban. So Kanban is again another Japanese word, and it focuses on ensuring that we can accomplish lean by having what we call a card system. Okay, so Kanban system basically focuses on how do we ensure that we have exactly what we need, okay, and when we're close to running out of product, that additional product comes in, so the system never stops because we always have a flow of product coming in as and when needed. Okay, Kanbans usually come with Kanban cards, and if it's for parts, it could be in containers. Kanbans don't necessarily have to be in containers. but this is a good illustration of what a Kanban system would be. Okay, and basically a lot of Kanban systems usually follow a 2-bin system, and I'm going to bring out my pencil to explain this better. So Kanbans, if we're using a 2-bin system, usually have product brought into the system in those 2 bins. Say we have 100 parts here, maybe 100 parts here, and each bin usually would have a card listing what's in the bin and how much parts are in it and so forth. And the 2-bin system usually works such that an operator will be working on one bin, and while he's working on one bin, the other bin will be getting product ready, such that when this first bin is done with, this empty bin becomes a signal that we need more product. And by the time this first bin here is done, the second bin should be ready to be used to get more product into the production process. Okay, so it's a continuous process throughout the course of the day, such that there's always going to be product available to the employee, but at the same time we're not holding on to a lot of inventory. We're always using just exactly what we need. Okay, and we're going to look at certain calculations that involve figuring out how many containers do we need, okay, and how much stuff should be in each container. Okay, and that'll be on the second part of this video today. Okay, so I think that's basically all the theory that I wanted to talk about. Okay, for the second part of this video, I'm going to be discussing Kanbans again, or what's this Kanban calculation here, and then I'll be looking at value stream mapping. What's a value stream map, and how do we use that within the production process to make for more efficient flow of product into the system. Okay, all right, thank you.